buenos días. Y, perdón, yo hablo castellano. Ok. Y yo soy brasileño. Y lo siento por Neymar. No sé si a ustedes gustan Barcelona, pero... Bueno, yo voy a hablar en inglés, que es más fácil para mí. Creo que todos para una charla técnica no es un problema. My name is Bruno, and this talk is about serverless and integration patterns, specifically Apache Camel, which is a framework that I enjoy using and playing with it. In fact, contributed to the project years ago with a component that is actually fun, Twitter. So you can search tweets, post a tweet using Camel. This talk is about how to combine serverless and enterprise integration patterns, if it makes sense, if it doesn't, when and why. And I hope you guys like it. So I've been to Microsoft for about 4 months. I joined this year in February, and I'm leading the Java team at Microsoft. And I use a Mac, and my VMs on Azure are Linux, and I write Java. So I don't know what Windows means, and I would like to continue like that. If you do want to follow me on Twitter or send me an email for information about Azure, about Java at Microsoft in general, feel free to contact me. I do have a Medium page, medium.com/@BrunoBorges. Feel free to follow. I don't blog that much. When I do, it's something that I'm actually passionate about, and I spent a couple of days working on. So feel free to check it out. Okay, and I'm part of the developer advocates team at Microsoft, and the reason I have this slide here is because we are hiring developer advocates and people to help engineering teams build solutions for developers, and also work with the community and engage with developers and customers and companies and partners and everyone who builds solutions. Okay, so for this talk here, what is serverless? A quick overview about it. How do we do serverless? And I'll show you some options, and then how you can do that on Azure. And then we're gonna talk about, I'll show you a bit on how much it costs, serverless in general. I'll open the page and give you an idea of price. And then we're gonna actually talk about enterprise integration patterns. So what is serverless? First of all, it's the idea of abstraction of servers. It's just that you don't care about servers. You don't care about the operating system. You don't care about the storage, the disks. You don't care about memory. You don't care about networking. All you care about is, here's my function, here's the entry point, that's the output, and that's my code that will process that information, whatever that is. Most of the time, it's event-driven. And by events, you can think about, first of all, HTTP. It's sort of an event. But other events also happen, like storage events, when an information is stored on your storage environment, or some information is stored on the database, or an event happens on a queue, like a JMS queue, or a Kafka queue, or any other forms of streaming events platforms. Those might be ways to trigger a function. And most important is microbilling. So you want to get charged by the execution of that function, not by the availability of that function in the cloud. Let's say you deployed a function and it sits there for 1 year and nobody calls it. Perfect. You just built a solution that didn't cost you anything, but also nobody used. But at least you didn't pay for it in the sense of paying for the environment where that function sits on. If someone does call that function, then there is a charge on per execution, per time that function takes running, by the amount of data that navigates inbound, outbound. There are many ways that functions might be charged in the cloud. So it's really up to you to find out your cloud provider, and then identify the billing methods that they provide. So, I wrote this slide so you can basically take a photo if you want, but that's my TLDR of what is serverless. It's basically what I said, but in a form of a slide. If you do want to dig into serverless architecture, you can check out the URL at the bottom from Martin Fowler, where he writes down about microservices architecture. I'm sorry, serverless architecture. Okay, so why people thought about serverless? Why everybody is thinking about doing serverless these days? Well, if you think about the past, we used to own the hardware, and we would have to manage the server. So we would have to buy an actual machine, go to Dell.com, HP.com, Lenovo.com, and buy an actual hardware, and then set it up manually, right? In the end, you have no life because you have to manage everything. You have to set up, install this operating system. You have to set up the firewall, connect the cables, the power cable, the networking cable. You have to crypt the network, brown, white, black, yellow, combine the colors of the internet cable, and it's like, yeah, it's a nightmare. But in the end, you do have a server, and you have full control over it. But people realized, not everything on that server is actually important that you need to manage by yourself. So then came the idea of virtualization. I want to virtualize all my hardware and just want to have an operating system that I can log into and manage myself. So all you are asking for is an SSH access. And then from there, you can set up everything. And then we thought, okay, I don't want even to set up my operating system and install things and download Apache and configure httpd.conf. I just want to, deploy my application and have it running somewhere so I can call the web server. And then came this idea of containerization and doing everything in containers. And in the past 3 years, we saw this boom of Kubernetes as the perfect orchestration platform. And then in the end, you just ask someone, or you ask yourself or the cloud, from the cloud vendor, hey, give me a Kubernetes cluster. And then from there, you just deploy your container. And then came the serverless architecture. People felt like, why? I don't even need to run a container. I don't care about the container either. I don't want to have to write a Docker file. I literally don't care. So came this idea of serverless platform, where you don't care. You just write the function and you deploy. So in the end, you have a function that's running on the internet somewhere, or maybe on your internet, and it's connected to something that triggers events, and then you push that data out to somewhere else. Okay, so I like this idea of serverless. I want to do it. There are different ways that you can do it. Most common ways that we all heard about are AWS Lambda, Azure Functions, Google Cloud Functions, and maybe you have heard about Pivotal Cloud Functions. It's a new project based on Project Riff, and then that takes us to the section, the first section of this slide. There are different open source frameworks out there that implement a serverless platform, and this allows you to run your serverless platform on your own environment. But Bruno, you said I shouldn't care about serverless. Well, you shouldn't care about setting up the environment to deploy something. Once that environment is ready to be, so you can take advantage of it for as many functions as you want, then that's okay. So you set up once your function as a service platform, either on-prem, on your own data center. For many reasons, you cannot use public cloud. And then you do have a serverless platform that you can take advantage of. And then your developers will use that, and they don't have to set up different environments for different applications. They just deploy functions. A common project is Apache OpenWhisk. IBM is perhaps one of the biggest contributors of the project. OpenFaaS, that is today by Alex, is at VMware. So VMware is technically the main contributor of this project. FN project from Oracle, also open source, and Project Riff from Pivotal. And lastly, we have Kubeless, which is like a functional style that runs on top of Kubernetes clusters. So if you do want to run your own function as a service serverless platform, you have options. If you don't care, or you are allowed to use public clouds, then you have these other solutions at the bottom. Okay, I want to show you quickly how Azure Functions works, and then we'll talk about enterprise integration patterns. So first thing I want to show you on Azure Functions is we work with Maven. So I assume most of you work with Maven as well. I would guess 20% of the crowd uses Gradle, and there you go, a Gradle guy. So let's create a function here using the Maven archetype. So I would say con Microsoft Barcelona version 1 package Microsoft Barcelona app name, data center will be at West US, my resource group, and done. And then I'm going to do Maven clean package Azure Functions run. So what this will do is it will package the application as a jar file. It will bundle all the dependencies. So if you have a JDBC driver, if you have a Lombok, if you have Guava, if you have any sort of Java dependency, it will bundle everything on your on this project and then run and deploy locally on Azure Functions, so you can test this function on your server. So what I'm going to do here is just shut down this function that I had opened before and start over. So Azure Functions is, so FN project from Oracle is implemented in Go. OpenWhisk, I'm not sure of the language they use. I'm not sure if it, I think it's not Java. Oh, okay. So let's just clean up the environment. Yeah, it's all good. And let's start again. The Azure Functions runtime is actually implemented in C#, but again, it's just an implementation detail of the underlying platform. It runs any programming language on top of it. Okay, so we got our API here. I can just go to the browser, and I have my function here, and I can provide name equal Neymar, you'll suck, move to PSG. All right, hello Neymar. Yes, okay. So let's take a look at the source code to understand what happened here. So I'm gonna open on VS Code because it's just faster. I have IntelliJ here for the other project, and for quickly see projects, I'll just go to VS Code. Okay, so here's our function, a hello function. And the way it works is you provide a method annotated with function name, and that's basically the name of your serverless endpoint. In this case for HTTP, and it's triggered by HTTP. So that's why we got the URL /API/hello. It's because of this annotation here. Okay, so this is triggered by HTTP. This is the name of the trigger, just for metadata. The methods get and post, and no authentication at all, and that's it. So I'll just do a test here to show you post. So if I go to on code and I say, let's save this file as http calls.http, I can do get the URL and just call this request. And because it's not running, so we have to start over. And while that starts, let me do a post here. Same URL, no header, and the content is just my name. And here, the URL will be name equals Bruno. Okay, it's running, so here's the call, the return of this REST endpoint, and same thing with post. So get, I can say get and post. Bruno get, Bruno post. Okay. Now, this is a Java project, so you literally can use it, go to your Maven, your POM file, and just add it and open and combine dependencies and start enhancing your project as you wish, as you need. And also you can do integration tests if you want. You can mock your class, and your class, again, it's very simple. You can mock objects, and that allows you to test your integration test of your function. Okay, so now let's go back to the slide. Okay, I demoed function. Now, there's a thing with functions. Now, as you break your monolithic application to multiple microservices, the granularity of your application starts to get very high. And that's why I personally love monolithic applications. It's just like one GitHub repository, all the source code is in there, you build, you deploy, you run, you debug, everything in one single application. I love it, it's perfect, it's like dream. But then someone said, no, I want to separate that because my team is too big, its monolithic application became too big, and now I want to do microservices because then I can have my pizza teams and separate that, and then each team will focus on their little piece. That's great. Then we went to the microservice architecture style, mostly because of a better needs to manage the teams and how they work together, right? Of course, there are many technical advantages of that as well, scalability, high availability, et cetera, and so on. And then someone said, no, microservice is still not small enough, let's do serverless functions. And then now we have like a multitude of functions that represent the monolithic application. That's actually an interesting approach when you get a monolithic application and you get like functions of your application, functionalities of your application that you see like, this could be exposed as a REST API. You pull that from your monolithic application and you just deploy on your serverless platform, like a REST endpoint to get the thumbnail of an image. Why do you need that to be part of your monolithic application? Just run it as a serverless function, and there you go. So the problem that happens when you start to have functions or requirements that a function X needs to call function Y, and then Y needs to call Z, and Z needs to call A and B and C, and then you have this data flowing between different functions, and you don't know who is calling who to implement certain functionality. And that's integration problem. How do you track how that information is flowing through your system? And in the old days of SOA, that was resolved by service buses and definitions of service-oriented architecture, where you go to an XML file and see how the information is flowing. The more integration points your application has, the higher is the complexity of managing and tracking this application. So while you think, a function just calling another function, it's just a glue, well, it's not that fine, because now you start seeing stuff, you don't have a metadata to see who is calling who. So there are many ways in the serverless world where you can solve this. You can have an API directory, you can have gateways, and so on. But in the end, you still have to implement all of that. For business application, for business scenarios, for business use cases where you have units of functions that combined deliver a certain business functionality, but these functions are still reusable by other use cases, then you start to have an integration problem, and you need to clear that out and make sure that who is calling who is well documented. And how do you process that data flowing from one endpoint to another? So that's where enterprise integration patterns fit in. So who knows if this then that? Okay, a couple folks. All right. In short, if this and that is a system so you can write recipes that will process data from different sort of web applications. I got an email that says your receipt is ready. I'm gonna use an if this and that recipe to get that Gmail attachment and put on my Dropbox folder. Or someone sent me a picture and tagged me on Facebook. I'm gonna take a copy of that picture and save on my Google Photos. That sort of thing. So if this then that, it's pretty cool. In a sense, they are implementing some of these enterprise integration patterns. And if you want to take a look and you work on integration systems, this is very highly recommended book to read. And if you want to implement, there are many ways that you can implement. Most of the patterns are very simple. It's just like, it's just concepts of messaging systems and architectural definitions. So you can just implement as you wish, or you can use frameworks that have already implemented those. So Apache Camel is one. Spring integration is another one. Camel has a support for Java DSL. That's what I will use here. But you can also define in XML, Scala, Kotlin, and a couple other languages. So just a recap on enterprise integration patterns. So this is the message filter. Let's say I'm getting a bunch of messages from certain system, and those messages are getting into another system. And I figured that, my business user said, Bruno, we are getting messages that we actually don't need. Can you filter them? Sure. What do you need? I need low resolution raccoons pictures. Okay, cool. I'll give you a message filter. I'll just apply that. So whoever is pulling information or sending that information won't be touched or modified. They will continue to send all sorts of images of raccoons. And in the end, the system that processes those images will continue to process whatever image gets there. What I'm going to do is apply in the middle a message filter. And what I need to do is tell the sender to start sending messages to a new endpoint that has the message filter. And then the message filter will get information about, okay, what is the final destination? That information will be on the metadata, on the header of the message or whatever. There are different ways that the final destination can be bundled within the message. And that is actually, by the way, another pattern that's called dynamic routing. Okay. In Java, in Camel, this is implemented that way. So we need a route builder. We're gonna say, okay, I'm gonna get messages from whatever endpoint. In this case, it's direct A. Whatever message is sent to that endpoint, I want to filter based on the resolution of the image. And I'm gonna look at the header of that message and get the resolution. If it's equal to low, then that will pass. Anything that doesn't fit will get ignored. Okay, quick trivia. What's the name of this pattern? Can somebody figure out the name of this pattern? Splitter. There's one here, but someone said over there. Well done. This is called message splitter. I got one message, and I'm going to break down into units of messages. Now, it's pretty simple. Why should I do this? Well, because you can make these messages process in parallel instead of in serial order, right? In Java, in Camel, this is implemented that way. I'll just say split and the body. There are many ways of splitting a message. If it's a JSON, I want to use JSON path. If it's XML, I might want to use X path, or I want to use X query. If it's a text file, I want to separate by lines, or I want to separate by a regular expression, whatever. There are many ways that you can customize the DSL to split your message depending on the content type and some expression to be evaluated. But in the end, you have one single message being splitted into multiple messages based on your definition of how to split, and that will process different calls, hopefully asynchronous calls, to another endpoint that will actually process that information. Okay, so now I'm going to show you a bit of a complex, complete demo of Apache Camel that shows a bunch of patterns, and I'll try to walk you through those if we have time. Yeah, we do have time. So let's take a look at that. Let me kill this one. Okay, so this application here, what it does is it uses the camel Twitter component. It will look into Twitter, will search for a hashtag, and then we'll plot the images on the browser based on that search. I configure out of the box the hashtag Barcelona, and I hope we get nice pictures of Barcelona. I will do a warning that I try my best to filter. I tell the Twitter API, please filter content. Don't send content that's crap. So what I'm going to do is I'll run this, but I warn you, if something shows up that it's unpleasant, I apologize right away on behalf of Twitter, even though I don't work there. Anyways, let's just pray. Okay. So Maven package. And Maven. Okay, cool. So I have web server running here that actually there's a component on Camel that starts a web server for you if you want that. And there you go. For now, nice pictures. So, and I cannot zoom out more. This is the max that I can go. Okay, so what's happening here is the Camel Twitter component is processing Twitter API and filling in images and tweets based on that hashtag into the flow. If the tweet has an image, that will go to the web interface. That's basically it. Now, there are many things that happen in the background, like, for example, the statistics, 22 tweets, 23, 24, and there it goes. Like 3 images have been found, although for some reason one of them did not end up here. So let's take a look at the source code, just to understand a little bit what's going on. And it takes a while to shut down because the connection with Twitter API, I haven't done anything to clean that up. Oh, okay, cool. As fast as possible. Okay, so let's take a look at this source code here. Main Java, main app, camel route. There you go. Okay, so this is our main route that has a bunch of stuff that's happening here. Let's start with the very first thing. Let's use the Twitter component and filter the streaming API on Twitter, Twitter streaming API. It's like a fire hose, it just sends stuff. I'm gonna use a keyword that's on my resources file, application resources file. It says hashtag Barcelona. And I want to send that to this endpoint here. It's just a in-memory like endpoint. Okay, now whatever gets to here will end up in this endpoint. And now I start processing that message, that exchange. The first thing I'm going to do is I'm going to extract the image of that tweet if there is an image. So this is a sort of message filter. I'll explain later how this is done, but here it is. Like I check the Twitter4j API. If there is a media entity on this tweet and it's more than 0, give me the first image because I don't care of the rest of the images. I just want 1. So get only the first image. And then I just convert that into a simpler Pojo that I wrote on my own project here. Here's a tweet pro Pojo, with the username, the text, and the URL of the image. So what I'm doing is the browser is rendering that image based on the URL. Okay, and then I sent this tweet as the inbound message, overriding the complete tweet that I got from Twitter4j. Okay, now I'm going to process a statics processor. That's what will give us this information here at the top, 27 tweets, 3 images. So the statics processor just gets that exchange. If it's a status, I increase the tweet count. If it's a tweet, I increase the image count. So what it does is, okay, status increases this one here, 27 tweets. If it's a tweet, meaning my tweet, my converted tweet, it's a tweet count. And this module will then be exposed from time to time, like a cron job, through WebSocket to this interface. Okay. And then continuing, okay, so I'm gonna filter everything that is tweet. I only will take things that are tweet, meaning my API, my POJO. If it's a status object, I don't care, just throw away. And then I'm gonna throttle. Why am I throttling? Because the Twitter streaming API is huge. So I'm fire hose with like many tweets per second. I only want 4 per second. So that's my rule here. I want to throttle the messages. And when you are building enterprise systems, you might want to throttle messages as well. Then I'm gonna marshal that and convert. This is for caching purposes that I'm actually not using anymore. And then I'm gonna marshal that and convert that object into a JSON. And then I'm gonna process that and convert it into a string, and then I'm gonna send that over WebSocket to my application, my web application that's pulling this information. So I do have a JavaScript code that connects to the WebSocket that Camo starts and starts pulling the information over there. Okay, so what sends the statistics? Well, it's a cron job. Every second, I will send the statistics processor, the current statistics. I'm gonna send over as a JSON object, again, as a string, to WebSocket on the TDCO/statistics. There are the WebSocket things that I do here. So I actually have a JavaScript that I can go on the Chrome console and call WebSocket API and make some changes live. I won't do that here because I don't remember, honestly, out of my head. But if this source code is on GitHub, if you want to check it out later, you can find it. But here's the command: search, sample, and you can make some live changes. Okay, so this is how Camo works. And generally speaking, you can literally combine lots of components: CETA component, Twitter component, Quartz component. There are components for CXF, calling web services, REST APIs, databases, AWS services, MongoDB, Cassandra, Kafka, etc. So speaking of Kafka and speaking of serverless, now let's take a look at how we combine these things. And let's just go back quickly here to the slide before we go for the final demo. So once you have learned these patterns, it becomes easier to come up with the solutions. You start. It's simpler when you know the patterns. It's just like Java patterns, like Django 4, design patterns for Java applications. Integration patterns are the same thing. Once you know a bunch of them, you don't need to know all of them, but once you know enough and you face a problem, it becomes easier for you to find the right solution for it. You know what to do. And then it just becomes a matter of how to implement that, but you know exactly what to do. When you think about serverless, though, how do you combine these things? Why? So some ideas are identify a message solution for a common problem. Sure, I want to implement that business logic that glues the units with functions. So that all those little pieces of Java code, like converting the tweet and just extracting the information that I need, that is a pattern, and I could implement that with a function. And then I can break that down, this huge route, into different serverless functions and just combine them eventually. If you do want a more solid integration solution, there are many in the market, and I think they are still the best. But in terms of serverless, none of them provide a capability out of the box, except for some that are cloud integration services. These ones come with serverless integration out of the box. So on Azure, there is this service called Azure Logic Apps. I think Amazon has one similar to this one. But basically what it does is it provides you this UI where you have components. And it's very similar to if this then that. You start combining components and the message will flow. And eventually you want to call a function to have a custom business logic. And you can just go add serverless function open editor and write some JavaScript code right in the browser and process that information. If you do want to use Java, sure, deploy that Java function and call the REST endpoint, and that's it. So let's take a look at the more concrete demo from serverless. So here's my Camo Azure Functions demo. What I'm going to do is I'm going to start this project from scratch. And I was tweaking this code before the session started, so I hope it still works fine. If it doesn't, we'll see together what's happening. Okay, cool. This code is actually, I mean, it's still like proof of concept. So many pieces are not best practices, many pieces are hard-coded and so on, but it's still valid to understand and see where these can go. So let's go to IntelliJ, where I've been working on this project. And you cannot see, yeah, because, damn it, I forgot to end the PowerPoint, sorry. Okay. Lucky yours, you didn't see anything, just me starting the terminal, and that's it. Okay. Can someone shout me how to zoom IntelliJ on Mac? Hmm? Yeah, no, it's not working. See? That's why I'm very bad with IntelliJ. I guess. Sorry. I've been coding on IntelliJ, but for demo purposes, I'll back to VS Code. And it's just one Java class, so I won't be navigating that much anyways. All right, cool. So here we are. And there's a bunch of stuff happening here. Let me try to get started with something very simple, okay? I got here some HTTP calls that I can make, and these will trigger Camo routes, okay? All right, first one is upper. I'm gonna send some text, and I want this function to return uppercase. So I'll just do, wow, okay. Open, okay, here we are. Send request. And I got return Bruno Borges. All right, so this is pretty simple. I mean, it is actually simpler to implement this without Camo than with Camo. But again, I just want to have a starting point so we can understand how this works. And let me close this window. Okay, here we are. So the uppercase function is this one here. Okay, so let me just break down a little bit so you can focus on it. Again, it's an HTTP trigger function. It will get a body. In this body, if it's post, it will be body. If it's a get, it's from the parameter body. So I could do get localhost, hello, I'm sorry, upper, and name equals Barcelona. And I need to separate it. Okay. Oops, body. There you go, Barcelona. Okay, so how does this work? Well, it gets the string from the HTTP call and creates an exchange in Camel. Using the Camel context that was already created when this Java class that hosts this function was created. Then I use a producer to start that exchange with this route. I get the output message of this exchange. There's an input message that's a message from the HTTP, and then an output, the response from the integration. and then I return that over to my HTTP response in a 200. Where is this defined? Well, the camel context is created here in the constructor of this class, camel function, and I create the context over here, right? And I provide some configuration. In the end, I have a route, 2 uppercase. And I just literally got the inbound message, 2 uppercase, and set as the body of the output message. And that's it. That's the integration that I did with Camel, and Camel runs on Azure Function. Pretty nice. Okay, but this is not the cool part. The cool part is I have this message that I need to send to Kafka. You can extend the Kafka library, write some Kafka code, and just do that, or you can use the Camel component for it. It's actually simpler to use Camel component for that. This is how you do it. You can have a route that says, okay, from endpoint Q on Kafka, I will convert this body into a string, and I'm going to create an exchange with the header, the ID of the partition, and then a random key for that information that I actually don't care. So, and then I would just send that to Kafka messages. And Kafka messages is an endpoint that was configured based on all this information here. This is the Kafka configuration. So where is my broker? It's on Azure. Here's the authentication string. So there's a very nice hash code here, access key, the SSL configuration, SASL mechanism plane, and so on. And that's it. All of this information I just got from the Event Hub dashboard. Let's just run it, and then we'll see what's going on. So I have here send to Kafka, and I'm going to send actually to a message splitter, because my use case is this. Imagine you have a mobile application that sends a JSON file, one single JSON file, one single call to the server. But you want to split that message into unit messages, units of work, and then you're going to put that on your Kafka topic. So I would send this to message splitter, and I want the final destination to be Q on Kafka. And I want this method to be called using post. And here's my JSON object. It's a bunch of codes. It's an array of codes. So I want to split this array into 4 unique messages. What I'm going to do is just call this post. And what happens is it starts processing this information. You see here the message. That's the message that was sent from the array, one unique message. And it was triggered, sent to Kafka. How this was implemented. Here's the last code from that array. So it's right over here, TBSA. And you have here TBSA. Now, what happened here is I do have a function, serverless function, that has it's a little bit smarter. And also I have a split pattern, how I'm going to split this JSON file and where I'm going to send it to. So let's look at the code for this. Here's the message splitter route. So I want to convert to string. I'm going to look at the content type. If it's application JSON, I'm going to split using the JSON splitter. So the JSON splitter right over here. Okay, I want to split JSON path using a JSON path that is inside the header split pattern that came from the HTTP call. And I'm going to stream that, so I'm going to have these 4 messages being called asynchronously to the final destination. And the final destination is processed by dispatch. So dispatch gets the destination from the header again, and uses that as an HTTP URI for the Kafka destination. And the destination method is post, but since I'm sending to Kafka, it's ignored. And the final destination is Q on Kafka. That is this service here. Q on Kafka, message splitter, message filter, Q on Kafka. So I get that body. If there's nothing, it's a missing value. I'll look at that later. And I'm going to send to Q Kafka. And I'm going to just go up here and here we are. I'm going to convert the body, set the header partition key again, 0, a random key, and send to my Kafka topic. And that gives me messages on my Kafka messages that are on my Event Hub on Azure. And this is Azure storage because I configured my Kafka, my Event Hub, to store whatever message it gets and capture those messages into Azure storage automatically. It's just a single checkbox. So here I have one file from this was one of the first executions that I did, not from today, not from right now. So I'll just download this one, replace, and I'm gonna go to my console, and I'm gonna do javaman jar, and I get the messages that were sent using Kafka through Camel, through serverless. And then once you have this set up, you can imagine that you can start combining serverless endpoints and routing framework like Camel, and combine your many components that Camel provides to implement your own solution of if this and that in this scenario. And if you do want to take a look at the Kafka service that we provide, when you go to Azure portal, you go to Event Hubs, and you just create an Event Hub, and it says, okay, I want to expose a Kafka API. So anything works fine. Anything that you have already working with Kafka works with Event Hub on Azure. I'll put some links here for you guys to take a look, because I think I ran out of time. So yeah, I'm out of time. So I'll just lend out these URLs here. So if you want to take a look and learn more about Azure Functions, Logic Apps, and documentation in general for what we have, these are some links to get started. And I have 2 minutes. Any question? Or does anyone is curious about code, want me to go back to the code? Anything? Nope? Okay. So you see Safari? Damn. I'll just leave it. And I'll be done. Okay, that's it. Thank you very much.